Hey there, science fans. Welcome to another exciting journey into the wonders of our universe. Have you ever stopped to think about the incredible power of the sun? This massive star at the center of our solar system is not just a source of light and warmth. It's a giant ball of burning gas, millions of miles away. And yet it provides all the energy that makes life on Earth possible. Pretty amazing, right? The sun's energy drives our weather, fuels plant growth, and even powers the ocean currents. Now imagine if we could harness that power directly. Think about the possibilities if we could capture even a fraction of the sun's energy and use it to power our homes, our cars, and our cities. Well, guess what? We can. Through the use of solar panels, we have the technology to convert sunlight into electricity. It's called solar energy, and it has the potential to change the world. Imagine a future where our energy needs are met by this clean, renewable source. Solar energy is energy from the sun that we capture and convert into electricity. This process involves photovoltaic cells that absorb sunlight and generate electrical power. It's a clean, renewable source of energy that doesn't produce harmful greenhouse gases. Unlike fossil fuels, solar energy doesn't pollute the air or contribute to climate change. And the best part, the sun provides more energy in a single hour than the entire world uses in a whole year. That's an astonishing amount of power just waiting to be tapped. That's a lot of power. Imagine the impact on our planet if we could harness even a small portion of this energy. In this essay, we're going to explore the exciting world of solar energy. We'll delve into the science behind it, the technology that makes it possible, and the innovative ways it's being used around the globe. We'll learn how solar panels work, discuss the challenges and opportunities, and discover why solar energy is so important for our future. From residential rooftops to massive solar farms, the applications are endless. So buckle up, science enthusiasts. Get ready to be amazed by the potential of solar power and how it can transform our world. It's time to dive into the fascinating world of solar power. Let's embark on this enlightening journey together. And so, how do we actually capture all that energy from the sun and turn it into usable electricity? The answer is solar panels. These ingenious devices are like sunlight magnets, converting the sun's rays into clean energy. But how do they work? Let's break it down. Imagine a solar panel as a sandwich. The bread of this sandwich is made of special materials that conduct electricity. And the filling, that's where the magic happens. It's made of a material called silicon, which is found in regular sand. Now, silicon has a unique property. When sunlight hits it, it gets energized and releases tiny particles called electrons. These electrons are like little packets of energy, and we can use them to create electricity. To understand how solar panels create electricity, we need to zoom in even closer to the world of atoms and electrons. This microscopic realm is where the magic happens, transforming sunlight into usable energy. A solar panel is made up of many smaller units called solar cells, and each cell is like a tiny power plant. These cells work together to capture sunlight and convert it into electricity, powering our homes and devices. Inside a solar cell, we have two types of silicon, N-type silicon and P-type silicon. These materials are specially treated to have different electrical properties, setting the stage for energy generation. You can think of them as two dance partners, ready to create some energy. When sunlight hits the solar cell, it energizes the electrons, making them dance and move around. N-type silicon has extra electrons, those negatively charged particles we talked about earlier. These electrons are free to move. Much like dancers eager to find a partner, it's like having a few extra dancers on one side of the dance floor. These dancers are full of energy, ready to leap into action. On the other hand, P-type silicon has holes, which are like empty spaces waiting for electrons to fill them. These holes are positively charged, creating an attractive force for the electrons. It's like having a few empty spots on the other side of the dance floor, just waiting for those extra dancers to come over. The stage is set for an energetic interaction. Now, when these two types of silicon come together, they form what's called a p-n junction. This junction is crucial because it creates an electric field that directs the movement of electrons and holes. This junction acts like a gateway between the two sides, and it's where the real action begins. When sunlight energizes the electrons, they move across the junction, creating an electric current. This flow of electrons is what we harness as electricity, powering everything from our lights to our smartphones. Remember those tiny packets of energy from the sun called photons? Well, when photons hit the solar cell, they energize the electrons in the silicon. It's like the music starts playing and the dance party begins. These energized electrons then jump from the N-type silicon to the P-type silicon, crossing the PN junction. It's like those extra dancers rushing over to fill the empty spaces on the dance floor. This movement of electrons creates an electrical current, which is the flow of electricity. To capture this electrical current, solar cells have metal contacts on the top and bottom. These contacts act like wires, channeling the electricity out of the solar cell and into our homes, schools, and businesses. And that's how we turn sunlight into electricity. It's a fascinating process that combines the power of the sun with some clever engineering to create clean, renewable energy. Section 5, Efficiency and Lifespan, the remarkable durability of solar panels. Now, you might be wondering, how efficient are these solar panels? Well, they're getting better all the time. Current commercial solar panels can convert around 15 to 20% of the sunlight that hits them into electricity. That means for every 100 units of sunlight, we get 15 to 20 units of electricity. But wait, there's more. In laboratories, scientists are developing even more efficient solar cells that can reach efficiencies of over 40%. That's like getting twice as much electricity from the same amount of sunlight. And here's another amazing thing about solar panels: they're built to last. Since they have no moving parts, there's not much that can wear out. Most solar panels come with warranties of 25 years or more, and many can last for decades with proper maintenance. That means you can enjoy clean, free energy from the sun for many years to come. Section 6. Challenges on the path to a solar future. Solar energy sounds pretty amazing, right? And it is. Harnessing the power of the sun to generate electricity is a clean, renewable, and sustainable way to meet our energy needs. It's a technology that promises to reduce our reliance on fossil fuels and decrease greenhouse gas emissions. But like any superhero, it faces some challenges. These challenges can sometimes seem daunting, but they're not insurmountable. With innovation, determination, and collaboration, we can overcome these obstacles and pave the way for a brighter solar-powered future. Don't worry though, we're up to the task. Engineers, scientists, and policymakers around the world are working tirelessly to address these issues and improve solar technology. Let's dive into some of the key challenges and explore the solutions that are being developed. Let's look at some of these challenges and how we can overcome them. By understanding the hurdles we face, we can better appreciate the efforts being made to make solar energy a viable and widespread solution. One challenge is that solar energy is intermittent. This means that the amount of energy generated by solar panels can vary depending on the time of day, weather conditions, and seasonal changes. The sun doesn't always shine, right? On cloudy days or during the night, solar panels can't produce electricity. This intermittency can make it difficult to rely solely on solar energy for consistent power supply. Cloudy days and nighttime mean we need ways to store the energy we generate when the sun is out, so we can use it when it's not. Energy storage solutions like advanced batteries are crucial for ensuring a steady supply of electricity. Luckily, battery technology is improving rapidly, and we're finding innovative ways to store solar energy. These advancements are making it possible to store excess energy generated during sunny periods and use it when the sun isn't shining. Another challenge is the uneven distribution of sunlight. Different regions of the world receive varying amounts of sunlight due to their geographic location and climate. Some parts of the world get more sun than others, but that's okay. We can still make the most of solar energy by strategically placing solar farms in sun-rich areas and using technology to distribute the energy where it's needed. We can connect different regions with a smart grid, sharing solar energy from sunny areas to places with less sunshine. This interconnected system can help balance the supply and demand of electricity, making solar energy more reliable. And of course, we need to talk about cost. While solar energy has become much more affordable in recent years, the initial investment can still be a barrier for some. The cost of purchasing and installing solar panels can be significant. While solar energy has become much more affordable in recent years, the initial investment can still be a barrier for some. However, it's important to consider the long-term savings and benefits. Once you have solar panels, you're generating free electricity. But remember, once you have solar panels, you're generating free electricity. Over time, the savings on your energy bills can offset the initial costs, making solar energy a cost-effective option in the long run. Plus, government incentives and financing options are making solar energy more accessible than ever before. Programs like tax credits, rebates, and low-interest loans can help reduce the upfront costs and encourage more people to adopt solar energy. Section 7, the land question: finding space for solar farms. Now, some people wonder, if we want to power the entire world with solar energy, won't we need a lot of land for solar farms? And it's true, we will need land. But it's not as much as you might think. Think about it. We already use vast amounts of land for things like agriculture, transportation, and buildings. We can install solar panels on rooftops, over parking lots, and even on water. Yes, you heard that right. Floating solar farms are becoming increasingly popular. They offer several advantages, like not taking up valuable land space and benefiting from the cooling effect of water, which can make the solar panels more efficient. So while we do need to be mindful of land use, there are many creative and innovative solutions to accommodate the growing need for solar energy. Section 8, a beacon of hope: solar energy for the developing world. One of the most exciting aspects of solar energy is its potential to bring electricity to people who have never had it before. Over 1 billion people worldwide lack access to reliable electricity, especially in rural areas of developing countries. Imagine a world where children don't have to study by kerosene lamps, where hospitals can rely on a steady power supply, and where communities can thrive with access to clean, affordable energy. Solar energy can make that vision a reality. Solar panels are relatively easy to install and maintain, even in remote locations. They don't require extensive infrastructure like power lines, making them ideal for bringing electricity to underserved communities. By empowering communities with solar energy, we can improve education, healthcare, economic opportunities, and overall quality of life for millions of people around the world. Section 9, a future powered by the sun. As we look to the future, it's clear that solar energy will play an increasingly important role in our lives. With its abundance, cleanliness, and affordability, solar energy has the potential to transform our world for the better. Imagine a future where our cities sparkle with solar-powered buildings, where electric cars run on sunshine, and where clean, renewable energy powers our homes and businesses. This is not a distant dream, it's a future within our reach. By embracing solar energy, we can reduce our dependence on fossil fuels, combat climate change, and create a more sustainable and equitable world for generations to come. Section 10, conclusion: embracing the solar revolution. So can solar energy power the entire world? The answer is a resounding yes! The sun provides more than enough energy to meet our needs, and with continued innovation and collaboration, we can harness that power to create a brighter future. Solar energy is not just about technology, it's about people. It's about empowering communities, improving lives, and ensuring a healthy planet for generations to come. It's about harnessing the power of the sun to create a more sustainable, just, and equitable world. So let's join hands and embrace the solar revolution. Together we can create a future powered by the sun, a future filled with hope, innovation, and endless possibilities.